All right, dear students, in this video session, I will be explaining you about the carboxylic acid chemical properties and preparation. First of all, just you have to know how do we prepare the carboxylic acid. We can prepare them using oxidation of aldehydes. Just know the name of this silver mirror tolerance test. Also, know we are changing from an aldehyde to carboxylic acid. And remember, for if it's oxidation, we should write it like an O. And know the conditions for now. Also, we will be working on this in the laboratory for AA2 in future. Just know these conditions, know the name of the test, also know this reaction and the conditions. Regarding the chemical properties of carboxylic acids, this is quite simple. You have to remember one main major rule is that metal replaces hydrogen from carboxylic acids, especially which hydrogen, the one that is located in the functional group. So this hydrogen. Please don't forget that. They can go reaction to hydroxide. For example, you have to know just this is hydroxides. Whenever we have CO3, this is called carbonates. Also, whenever this is HCO3, remember that it's called bicarbonate. So know what's hydroxide, what's carbonate, and what's bicarbonate. The rest is quite simple and straightforward. So know that we have this reaction. And metal is sodium, so it will replace hydrogen. What we will get, CH3, CH2, COO, Na. You see, it replaced hydrogen, and hydrogen will come to here as a water. One more crucial thing is that you have to know the valencies of the elements, and it's easier to find the valencies from the periodic table, which will be provided for you. Group 1 metals, their valencies are 1. Group 2 metals, their valencies are 2. We have few metals that are not in group 1 and group 2. And group 3, aluminum, valence is 3. But for the metals that are located in D block elements, usually they were given, but few of them, for example, you have to know that zinc valence is 2. Okay, but if it's an iron, it can have a valence of 2 and 3. We will tell you if it is 2 and 3, you have to consider that. But for zinc, this is only valence 2. In here, also, Na will replace hydrogen. This is sodium carbonate. Note that whenever we have in the reactant CO3, we have to get two products. So let me write it this one too. So we are going to get CH3, COO, and Na, sodium, plus water and carbon dioxide. Please don't forget that in the reactions with the carbonate, it can be sodium, potassium, zinc, etc. Always we are getting water and carbon dioxide. Please don't forget that. The same thing in here. This is bicarbonate. We have to get CO2 and water. And which hydrogen it will replace? Of course, this hydrogen. The calcium. Let's write this one. So we are getting CH3, COO, calcium plus H2O plus CO2. You have to take a look at metal. Calcium located in group 2. Valency should be 2. If the valency is 2, outside of the radical, we have to just put 2. Let's see what else do we have. Whenever they react with the metal replacement, you see, always it replaces the metal. How do we name these salts? First of all, why they are called salt? First of all, let me write, I always use this sodium chloride. This is a salt, yes. How do we name it? We name, first of all, metal, sodium, and then we name it acid radical. What's acid radical? Acid minus hydrogen. So acid is HCl. If you remove hydrogen from HCl, it becomes a radical. And sodium chloride. You see, for the salts, we always name metal first, then the acid radical. Let's see in this example, CH3COO lithium. How do we name it? We name the metal first, lithium, then we name acetate. Also, you have to know that one carbon is called formic acid. If it is a carboxylic acid, we say formate. Two carbon, acetic acid. If it's a salt, acetate. Also, to make it easier, you can also write ethanoate. It doesn't matter. You can either write lithium ethanoate or acetate. We have 4 carbons, butanoate, or remember, we had 4 carbons butyric acid. This is one of the things that you have to know. This is called, if it is C6H5COO, this is called benzoate. Please don't forget this. Let's name, for example, this molecule. So what will be the name of this? It will be calcium. We have to name metal first, and we have 2 carbons in the, don't consider this, only consider, take a look at the parentheses, 2 carbons, so we can name it acetate. Okay, so calcium acetate or ethanoate. Now let's take a look at neutralization reactions. The same thing. Neutralization is between acid and base or alkali, yes? So this is a base, basic oxide. This is an alkali, sodium hydroxide. The same idea. Metal replaces hydrogen. Metal replaces hydrogen. In both cases, we are getting water as a product. But whenever this is an exception, we so far we have learned that metals, whenever we have metals, it replaces hydrogen, yes. But whenever they react with the ammonia, especially halogen derivatives, always remember that whenever they reacted, always one hydrogen from NH3, chlor takes it. So and become HCl, and the NH2, remaining NH2 will come replace chlorine. So let's take a look at question number 2. So we have this chlorine, yes. We have to remove this chlorine. So let's write it CH. And this chlorine takes H from one H from NH3, so HCl. And after removing one H from this ammonia, we have NH2. It replaces this chlor 2. So we can write NH2, and anything else the same in this reaction. Only change chlor and H and NH2. The same thing in here. Instead of chlorine, NH2 comes in here, and everything else is same. We are getting HCl. Esterification. Esterification is the reaction between carboxylic acids and alcohols. We are getting esters and waters. So let me tell you my way of writing that I have already written. Imagine we have alcohol. The alcohol name is ethanol, by the way. Ethanol, and this is methanoic acid. Methanoic acid. What do I always do in order to write esterification reaction? I always shift the either methanoic acid or ethanol particles just to make sure that OHs are colliding with each other. They are face to face each other. Always remember that from carboxylic acid, we have to remove OH, hydroxy group. From an alcohol, we have to remove H. So imagine we are removing this, we are getting water, yes? And what you should do next, you have to just combine them. So hopefully you got the idea. First of all, make sure that OHs are face to face each other, and remove H, remove OH, and combine these oxygens together. And in terms of the nomenclature, another crucial part. We said that this C2H5O part came from an alcohol, yes? In order to name the esters, we have to take alcohol as a prefix. Ethyl, because we have 2 carbons. What about carboxylic acid part? 1 carbon, we name it methan. We name the esters OAT at the end. Please don't forget that. Combustion is easier, we have learned it already. By the way, this is what kind of combustion? Complete combustion. Okay, if the question asks what's the product of incomplete combustion of ethanoic acid or acetic acid, the answer should be CO plus water for incomplete combustion. Hopefully you got the topic. Remember that always and always, whenever carboxylic acid react with the metal, it can be metal oxide, it can be metal hydroxide, or metal itself, always metal replaces hydrogen. But whenever it react with NH2, NH3, ammonia, hydrogen from ammonia takes the chlorine, and whenever it's a combustion reaction, in the reactant we should say O2. Whenever you see O2, know that this is a combustion reaction. Also, it should be a temperature in here. We haven't put that temperature, so this is combustion reactions. Thank you for listening.